Hello and welcome to Science Never Stops. I'm your host, Joseph Vick with the U.S. Space and Rocket Center, and today's topic is symmetry in action. Now, symmetry comes from a Greek word meaning to measure together, and is widely used in the study of geometry. And geometry is the mathematics dealing with shapes and angles and lines. Now, mathematically, symmetry means that one shape becomes exactly like the other when you move it in some way, where you turn it or flip it or rotate it on its side. Now, there are two types of symmetry. There is rotational symmetry, where an object has more than one line of symmetry, meaning you can cut, divide the image in half, fold it in half, so that in more than one direction the two halves will appear like mirror images of one another. So I have collected random objects in my house, so I wanted to give you an example first of rotational symmetry. So I have here a 5-pointed star. So 5-pointed star, and I have a knife here, so a bread knife. So this will represent the symmetrical lines drawn when I'm cutting this object. So rotational has to do with finding multiple lines. So there's 1, 2, 3, 4, 5 lines of symmetry with this star. So as you can see, rotational symmetry revolves rotational movement around the object to find multiple lines of symmetry. The second is reflection symmetry, where there's only one line of symmetry. So you can cut, divide the image in one plane, resulting in two halves, mirror images of each other. Human beings are like that. So just like our faces, you have two ears, two eyes, dividing our nose, dividing our mouth, and our head and our whole body. One arm on each, one leg on each, one hand on each, one foot on each. Now, reflection symmetry doesn't work in other planes. So if you sort of folded yourself at the waist down to touch your toes, your top half does not match symmetrically to your bottom half. So as a human being shape, we are reflection symmetry, not rotational symmetry. And then you have one more symmetrical object that is not symmetrical at all, and we call that asymmetric. A meaning non or none. And that's an example would be the NASA emblem. So notice, cut here, the two halves aren't equal. Cut here, two halves aren't equal. Even if I go here, the two halves aren't equal. So that's an example of asymmetry. Now, I encourage you to go throughout your house to find various objects and sort of lay them out on a table in front of you. And I want you to determine whether they are rotationally symmetric or reflective symmetric. So I'm going to go through a few of these examples that I have. And let's start with my boomerang. So I have a boomerang here which was given to me by Australian students that came through Space Camp. So hello to you all down under. So I have here an example. So let's take a look. So if I were to divide this here, we would have a mirror image on each side. Let's see if I try this way. No, not so much that way or that way. So I would say this is only one line of symmetry, meaning it would be reflection symmetry. So that would be the boomerang. Okay. I have a spoon. Again, let's divide our spoon here. Up, the top half does not equal the bottom half. Not there or there, but does look to be one right down the middle line of symmetry, so that would make it again reflective symmetry. All right, I have the TARDIS here. Dividing that in half. Seems to be equal on each part. Oh, but not that way. So that too would be reflection symmetry. What about the pot holder? We have here, disregarding the face in the middle, we have 1, 2, we go all the way around. We can have this one categorized as rotational symmetry because of multiple lines of symmetry. I have a sphere. Looks to be equal multiple divisions, so this too would be a rotational symmetry. My D20, D&D die, and this one would also be, disregarding the numbers, multiple lines of symmetry as well. So this would also be rotational symmetry. Joseph rocks, literally. Let's see. Oh, even disregarding the letters on the rock, this would be considered asymmetrical because it would not line up top or bottom. So symmetry is really great in nature and in items and aesthetically in art. So symmetry is all around us. I encourage you to go throughout your house and find various things to see what you can find to be either rotationally symmetric or reflection symmetry. And what do you think, and post the comments below, the most iconic piece of Huntsville, Alabama, the Saturn V rocket, what kind of symmetry do you think it may have? Post your answers in the comments below. And also remember, science never stops.